And now we're going to start back, and Joseph Hubbard from Creation Research should be with us. And Neil, if you can spotlight, or is Joseph there? I can see Joseph.
Hi, I don't know if you can see me or can hear me. I
Hi,
should be
Joseph.
here. I think I'm unmuted. Yep.
Yeah, you're unmuted.
Wonderful.
Hi, Joseph.
Yeah, it's good to be here.
Yeah, good that you're with us. And Joseph, do you just want to give a brief introduction to yourself and to the Ministry of Creation Research?
Yeah, sure. I've got a few slides and photos. Are you okay if I share screen and show some people the kind of stuff that I do?
Yeah, absolutely. Well, why don't you just incorporate that into your talk, and once you share your slides, just begin your talk, and you can incorporate the introduction.
Absolutely.
So, yeah, thanks for being with us, Joseph.
No worries, it's good. Let's see if this works. There we go, and see if that works. There we go. That should be good. We should be up and running. Lovely. All right. Well, thank you very much for having me, and thank you, Simon, for inviting me along. Hopefully you can all hear me nice and clearly, and you can see our website there, creationresearch.net, and you see myself there. You see our international director, John Mackay, and in between us, we've got a deadhead. Oh, that's a Neanderthal skull, by the way. We do a wonderful amount of research all over the planet. Me personally, I'm the director of Creation Research UK. I'm sort of look after the ministry in the UK, but get to travel over the planet doing some research, speaking and engaging with teachers and with schools and churches and universities and all sorts of wonderful stuff. This was in a very large school assembly sort of chapel in the morning in the USA, talking about snakes and poisons and bites and all sorts of stuff. Because you see, Simon has asked me to deal with the topic of the flood today. So my background is majority geology, and I love taking field trips. I love leading field trips all over the country and all over the world, in fact. And my main academic background, if you like, is in geology, specifically something called paleobiology. What's paleobiology? Well, a branch of geology is paleontology. You probably already know that. That's the study of fossils. And here's some wonderful fossils that I get to dig up. You can see me, this is a couple of years back now on the Isle of Wight, and you can see it's a large dinosaur skull that I'm working on excavating. Some fantastic fossils that the Lord has enabled us to find and do research on over the years. And paleobiology specifically deals with getting these creatures out of the rocks and actually trying to reconstruct ecosystems, trying to work out how these creatures lived when they weren't fossils, when they were alive on the planet. You know, one thing that I've noticed over the years as you dig these up, it really simply doesn't work, because the geology places that you're working on, the rocks and the fossils that you're digging up, are quite frankly a mess. You find things like plants and dinosaurs, land creatures and land plants mixed up right next to seashells and sea creatures. In fact, that's actually got a bit to do about what we're dealing with today. We don't just deal with the fossils, though. I mentioned my background in geology, my degrees in paleobiology, but I also, in order to pay for my university, because it's not cheap, this university lark, I worked as a zookeeper for nearly 6 years while I was earning my degree, and that actually led me on to them partially funding me to do a zoology qualification. So I'm qualified not just in geology and paleobiology, but also in zoology as well. So dealing with animals and working out how to look after them and the best way to set up their enclosures and stuff like that, but also the science behind how these animals actually work. As we travel around, we often film a lot of our stuff. This was a recent trip to Iceland, which was sort of part honeymoon and part research trip, or well, my wife thought it was mostly a honeymoon. I thought I can't help but sneak a little bit of research in there. We actually filmed a wonderful documentary, which is very nearly out. You can actually pre-order this at creationresearch.net as an MP4, and the DVD will be out very shortly. But we decided to do some research, not just on fossils, but also climate. I mean, you've heard about climate change and the melting glaciers, and hey, it's going on in Iceland. There's even a glacier which has been deemed extinct, and last year they held a funeral for it. And so we went to investigate and actually find out what's the full history of Iceland. Let's put it into perspective, and let's also give it a biblical history as well. And you can find out more about that at creationresearch.net. All right, our topic today, the flood. I mean, the flood encompasses a huge amount. I mean, we could just take the Bible and do a Bible study. We could look at fossils. We could look at geology, and we could look at one tiny little aspect of geology and spend all day in it. So when Simon asked me to deal with the flood, I sort of scratched my head a little bit and thought, what's the best way to actually approach this topic? Because it's a huge topic. And so I spoke to John Mackay, our international director, and we actually put together this little presentation, how to recognize a flood deposit. Because there's a big emphasis in creation literature, and it's absolutely fantastic when you look at things like rapid burial, when you look at things like, oh, this bed is so enormous, it covers most of the USA or most of Australia, or it's in England and it's in Germany, it's the same bed, this must be a big flood. But we thought, let's see if we can actually take all of these concepts and put them into a presentation which shows you how to actually recognize a flood deposit. And let's use some real practical and everyday examples that you can actually take these concepts and apply them to basically wherever you are. There's some really fascinating insights that you can find. Okay, so what are we actually dealing with? How to recognize a flood deposit? Well, let's start by defining what a flood is. I mean, if a tap bursts in your kitchen and the water sprays out and it goes all over the floor, you've got yourselves a flood. It's a flooded kitchen. Now, a flood by definition is water being where water shouldn't actually be. It's water not in its place, if you like. And so when you're actually looking for evidence of rocks, a deposit, a geological deposit, which has been laid down by a flood, you're looking for evidence of water being where water shouldn't. And mixed environments actually does this very, very well. I'm actually going to show you, I'm going to stop sharing very, very briefly, and I'm actually going to show you a fossil that we've got. We've got the Creation Research UK Museums project, and the Lord has enabled us to get hold of some absolutely wonderful fossils. I'm going to hold that up to the camera and hopefully it'll be in focus and hopefully you can see that. Can you see this curly whirly creature here? The little curly whirly shell? Most of you probably know that as an ammonite. We've got some more down here. In fact, if you get in really close, you can actually see all throughout this rock is full of these little sea creatures. And then we've got this big brown long thing in the middle. That is actually fossil wood. It's timber, and it's so well preserved we can actually tell exactly what type of rock it is or wood it is. It's actually from an Araucaria tree. Oh, you and I know these as monkey puzzle trees, or if you're from Australia or South America, they're known as southern conifers. Okay, here's a wonderful fossil. It's got sea creatures and it's got land plants buried together. You have evidence for a flood, just because you actually have got evidence of water being where it shouldn't be. I mean, either sea creatures have been brought onto the land by a flood, so a great big water deposit has actually taken that water and it's swept all those sea creatures onto the land, and it's caught it up with trees, or vice versa. The water has come, burst up out of the ground, and it's washed all the trees into the sea and into the sea creatures, and has deposited it all down in a mixed environment. And then, of course, you can look into, well, how quickly were they buried? How big is this bed? And so on and so forth. So we're looking for evidence of water being where water shouldn't be. We're looking for evidence of fast flowing water. That's indicative of a flood. We're looking for evidence of mixed environments. So land plants and sea creatures sort of buried together is a good piece of evidence. And we can also have a look at modern flooding events and scale them up and match them together. Because, well, one thing we know about water is water always behaves the same, whether you've got a little bit of it or whether you've got a lot of it. It just behaves in different quantities of the sediment. So we can actually use modern flooding events to actually match these up. See if my, there we go. Creation Research, you see the emphasis on research there, our museums project. You've seen a little bit, tiny little sample of some of the research and some of the fossils that we've got ready to go on display. You can find out more about this at creationresearch.net and the creationresearchcentre.com. The latter website there, by the way, is still under development, but there's still plenty of information up there. What we're doing, we're getting our museums project together, and we're actually going to start putting up a whole list of our entire collection, photographs and a little bit about it. It's a long-term job. We're developing the museums project in the UK, where we're trying to get all this on display and get it out there for people, so you can get behind and support us and find out more on these websites. But let's take you to one of our museums now. Let's go to Jurassic Ark. Now, it's not in the UK, unfortunately. It is in Australia. So unless, of course, you're in Australia, in which case go and see it when it's open and COVID is all over. But for us, well, it's 24,000 kilometers away from us at the moment. But there's some really fascinating research there, and some of the research is actually transferable over to the UK. There's Australia. There's where Jurassic Ark is. It's near Gympie. It's about a 3-hour drive north of Brisbane. I've been there several times myself when I was in Australia and doing some research, and we help out with the research sort of virtually as well. You can have some visits. You can come and visit it. You can see some of the wonderful research yourself. We have high school students come and find out the truth about the Bible. We have huge public gatherings when COVID isn't on and when we actually can do it, to see, well, can you see what they're standing around? Can you see the deposit? Can you see the rocks? Can you see sort of the long things there? This is actually because Jurassic Ark, the outdoor museum, is actually based on a real life fossil dig. A research.
Joseph, are you still there with us? It's frozen.
Can you hear me now?
Yeah, I can hear it. Froze for a moment there. Sorry, folks.
That's all right. It froze. I don't know what was going on there. It just kicked me out and then it's put me back in again. There you go. That should hopefully work. Slightly different angle, but that should work.
Yeah, you get back to it. If you just go back to where you were.
Yeah. Let's try this again. So we were talking about Jurassic Ark. Apologies about that, folks. We were talking about Jurassic Ark, and we were talking about some of the fossil digs that you can actually get there and can go and explore and dig up some wonderful stuff. Not just fossil digs, also dinosaurs. We have dinosaur track displays. We take groups around to, oh, by the way, this dinosaur track display, which was designed by our team at Jurassic Ark, actually got the thumbs up from the National Museum in Australia as being one of the best reconstructions of dinosaur trackways they'd ever seen. So there's some real world-class stuff going on here, including some of these fossils. Drowned dinosaurs? Oh yeah, that's another whole presentation, but there's definite evidence of drowned dinosaurs, and dinosaurs are so brilliantly accessible by people, so we actually introduced some virtual reality technology. You can see here we've got a Spinosaurus next to these school kids. Yeah, with virtual reality, you can have dinosaurs come alive, you can have dinosaurs fly over, you can dig up fossils and make fossils at Jurassic Ark. You can do some wonderful experiments as well with polystrate trees, and these are stuff that you can do, you know, at home. And all of our museums are designed around research that you can actually see happen on a visit, and that you can actually take that concept home to go and demonstrate to people yourself. Here's one particular experiment that I've been heavily involved in, the Strata Experiments. Millions of years to lay down sediment. Oh, we're dealing with a little bit like that today, but the reality is you can actually make these experiments where they produce entire deposits in just minutes. And you can see we're doing it there with some students and some children on a big group. You can do this as you watch. It really is rather fantastic, some of the stuff that you can do nowadays. Like virtual technology, Mega Shark, after their own kind. Yeah, well, how big was Megalodon? You saw our display of the shark's jaw there. There's Megalodon, the extinct shark, next to a diver. Virtual reality really helps to give you a big picture of this. You can do this when you come and visit all of our museums, and you use it with your smartphone, hold it up, and some wonderful virtual reality comes to life. And the point that we make is, well, for all intents and purposes, Megalodon was a great white shark, just a lot bigger. The teeth match up perfectly. Yeah, after their own kind. You see, all that's happened is sharks have devolved. They've not evolved, they've gone downhill, not uphill. And you also learn in these museums that all things were made by Jesus. Colossians 1:16, all things were made not only by Jesus Christ, but they were also made for Jesus Christ. And that's an extremely important thing that you have to get across. See, the Bible teaches that in the beginning, everything was created very good. Everything was created very good by Jesus Christ. And then the fall of mankind came, and we go downhill ever since to the flood judgment, the judgment of mankind in a worldwide flood, which is the topic of our session today. All right, let's take you to Jurassic Ark, and let's actually show you some of this research. Jurassic Rocks. Jurassic, by the way, named after the rocks in the Jura Mountains in Germany. Nothing to do with millions of years, nothing to do with evolution, everything to do with where they were first studied and how they were first studied. Okay, as you can see the history of our excavation as we've started to dug down and dig through these rocks. What are we actually finding in these Jura rocks from the Jura Mountains, which are also found in Australia? Well, the point that they prove is that it's not 150 million years old. What are we talking about? Well, there's a tree that's buried in these rocks. Do you notice there are no branches? It's just a log. You see, this is key in actually working out as we go forward how these rocks and fossils and deposits were actually laid down originally. Okay, no branches, no roots either. They're snapped off at the bottom. Interesting. Okay, keep digging down and you find that they're actually, these trees, these fossil trees are buried with boulders, huge boulders the size of my head. Okay, that's interesting. It makes an important point. So what we do is we dig these out, we give them a good old clean and a good old spray down. You have to paint them with special glue to stop them from cracking, because as soon as you've exposed them to the sun and the rain and so on and so forth, they can actually decay and break down pretty quickly. But the point is simple. This is not a fossil forest. You see, the standard evolutionary idea, the thing which I was taught going through university, was that when you come across these log deposits, when you come across these fossil forests or supposed fossil forests, these trees lived, they died, and they got buried where they were living. That's the standard assumption across all of geology when it comes to fossils, that these creatures lived, died, and buried in their ecosystem. And the evidence says, no, you actually need to have a full picture. What are we talking about? Well, there's a pine log. You can see Liam, one of our geologists at Jurassic Ark, working on one of these deposits here. You can see it's rained quite a bit because it's getting flooded around, but it's revealed something rather interesting. There's your pine log. There's the strata. Strata is layers, the layers of rock, which is just underneath the log. It is what the log is actually sitting in. Can you see the layers? Can you see the way that the strata is lying? Can you see the way that the tree is sitting? You see, the tree is actually sitting up through many of the layers. It cuts up through the layers. This is what's called polystrate. Polystrate was a name which was coined by Professor Derek Ager, who worked at Cardiff University in Wales. And he recognized that, hey, we've got a tree here that actually cuts up through many layers. Poly meaning many, straight meaning strata or layers, and you can see it clearly here. The layers are along, the tree is sitting up through the layers. We have a polystrate tree. There it is again. The strata is there and the tree is lying flat alongside it, the opposite way to the strata. Interesting. You see, the point that this makes is that the strata was deposited in less time than it takes the pine tree to rot. Pine trees are softwood. They rot pretty easily. So if you actually want to get a fossil tree, you need to bury it quicker than it takes for that pine tree to actually rot and decompose. In other words, this layer, these layers do not represent millions of years, but actually a quick process which buried the tree quicker than it took for the tree to actually decompose. What else can you find here? We love to have students and families come along and help excavate and dig these up. And you can see some of these smashed logs which have just been ripped in half, which are also polystrate. They sit up through many layers. Here's Gary, one of our helpers, who's digging out an enormous tree that we actually found. Notice there's the bulb of the tree, the base, no roots. All the roots have been ripped off completely. But what's really interesting is what Gary found at the top of the tree. You see the great big boulder there? I mean, this is actually our largest boulder we've discovered at Jurassic Ark. It's nearly 1/2 meter in diameter. That's a big boulder. And you realize that big boulders mean fast water, because there's a very important point. Logs float, rocks don't. If you actually want to have logs buried next to large boulders, you need water that's flowing fast enough to carry both the wood, the logs, and the boulders to actually bury them together. Very fast flowing water indeed. In fact, we've actually called this the fossil flood logjam. How do we get that? Well, let's actually compare it with some real life evidence. Let's have a look at a real life logjam. This is in Canada. It was the result of a massive landslide which swept down the mountain and ripped up the trees and actually dumped them into the lake. And you've got a logjam. You notice there aren't any trees, aren't any roots. You can see the bulb down in the corner there, but there aren't any roots. Do you notice most of the branches have been ripped off? They're just great big logs. Interesting. In fact, one thing you notice is as these trees float about and they bump into each other, they get abraded. And you end up with these sort of abraded, sort of slightly pointy ends as they float about. Okay, well, let's take you back to Jurassic Ark and have a look. Hey, fossil trees show the same abrading. This is a logjam. These have been floating along in water. They've been ripped up in a massive flooding event, ripped of their roots, ripped of their branches, and have been floating along, bashing into each other very, very quickly. And we know the water was flowing quickly because it's got massive boulders being carried along next to it, and they've become abraded. Let's just put them side by side for you. Oh yeah, this is a flood dump. This is a fossil flood logjam. Interesting what you can actually find when you take the big picture. Identification. These are also southern conifers. Oh, you remember the fossil we had out a minute ago from Charmouth down south with the curly-whirly ammonites and the fossil wood running through it? Yeah, these are southern conifers as well. There they are growing today in Australia. Their point, you see, as long as Araucaria trees or southern conifer trees have been on the planet, they've reproduced after their own kind, just like God commanded them to do in Genesis. And that doesn't matter whether you want to believe that the fossils are 150 million years old or just a few thousand years old. The one thing you can prove from them is that they've been doing exactly what God commanded them to do from the very beginning. And when you find that there is no evolution in the rocks in the slightest, you have no need to believe in the millions of years at all. These were created after their own kind. Evolution, or the millions of years rather, is an excuse to allow evolution to have happened. But there's no evidence for evolution in the rocks. Interesting. Okay, there you can see some more rocks. These rocks come in all shapes and sizes. They're very unsorted, from the tiniest little pebble to the hugest great boulder, and they're buried right next to these logs. Here's a new excavation that just happened a few days ago. Yes, we're right onto it with some of this research. You can see the broken log sections. You see how they're sort of dumped together. Yeah, this is wonderful evidence of a rapid dump. And the point that I made earlier is really very poignant in this picture. You can see the logs. They're all lying straight. You can see the boulders, the big ones, the small ones. It's not sorted at all. You see, if you have slow and shallow and gradual water movement, water is a very good sorter. It will sort them from small to big with the things that are floating on the top. What you see here is a mess. What has happened is that the water has flown so quickly that it's caught everything up in its path, whether it's a massive boulder, a light log, or a tiny little pebble, and it's dumped it all down quick enough, so quickly that it hasn't actually had chance to sort it out, to organize it into layers. Okay, log orientation. Orientation is very important when you're dealing with evidence for a flood, and we'll come on to that in just a moment. You see all of our logs. See how they're all pointing in roughly the same direction? In fact, a sort of a southwest to northeast kind of direction. Yeah, this is all over our deposit in Australia. In fact, the deposit at Jurassic Ark in Australia goes way beyond just Jurassic Ark. It in fact goes over most of the eastern side of Australia. It's absolutely enormous. And here we have this evidence of flowing water. Not just the fact that these logs have been knocked together, not just the fact that they're buried with massive boulders and tiny little pebbles, but the fact that they're all flowing in the same direction. You see, there it is again, northeast, southwest. orientation, broken trees, abrading, mixed dump, rocks all show the fact that this has been a flood deposit. You see these points, these concepts, you can actually take and apply them around the world. And let me prove it to you by bringing you a step closer to home, to the Creation Research UK Museums project. Yes, we have over 10,000 fossil and artifacts now in our collection. That's the latest estimate. The last count was actually done about 3 years ago, so it's not completely up to date. But since that time, we've accumulated an enormous amount through donations, through research trips, through practical trips around the world and doing this research. We will have now over 10,000 fossil and artifacts in our collection. The collections don't just include fossils, by the way. They include natural history, geology, archaeology exhibits, everything to show that the Bible can be trusted from the very beginning, including some real world-class fossils like this one, which was donated a few years back. You see big fish, you see little fish, you see how little fish is coming out of big fish's mouth. Yeah, there it is there. Fossil rocks are fast rocks. There's no doubt about it. Oh, but have a careful close look to where I'm pointing with my arrows. Can you see the little indentations of little fish's back? You see, when I first found this, I thought that this was a big fish halfway through eating little fish, and that he'd been buried so quickly that he hadn't even had time to finish his lunch. But if you actually look closely, it's something even more fascinating. You see, if you look at the teeth mark running down little fish's back, little fish has already been eaten. He's already been eaten and munched down. And then something so quickly, so suddenly, and so violently has caught big fish up and has squashed it with such violence that little fish has gone, whoop, and it's come out. Interesting. This is evidence of some extremely rapid burial. The Creation Research Centre, you can find out more about it at creationresearchcentre.com. That's the home of our museums project as we look to develop these museums around the UK. You can actually find out more about how to support the UK ministry, and in the following few days, we're still developing the website, but in the following few days, you'll start to see some of our collections go up there and see some of the absolutely fantastic stuff that God has provided for us. And you can also support us, not just through your prayers, not just through visiting the website and finding out more and donating and supporting. You can also visit our Creation Research store, where we've got some really fantastic and unique resources unique to Creation Research. Do make sure that you make use of Answers in Genesis discount code there, but also check out the Creation Research store, What Happened to the Dinosaurs, a wonderful research book, Tights, Mites and Fossil Fights, and your questions about creation answered. In fact, for this specific webinar, we've also there's Who Made All the Dinosaurs. We've also put up a special code. If you use the code AIG when booking out or checking out of our web store, creationresearchstore.com, you'll also get 20% off any of the Creation Research resources, including some wonderful fossils that we've put up there recently, so you can actually have your own evidence. Let's take you closer to home. In Australia, we've learned about some of the concepts behind floods and how to recognise a flood deposit. Let's actually take you to Hunstanton, a place which I know very, very well. And I've had a lot of time spent there digging up fossils. It was actually the subject of my first ever research paper. It was the subject of my dissertation. There's Norfolk to give you your bearings. That's my homeland. There's sort of the west of Norfolk. Hunstanton is just about there. It's a tiny little deposit comparatively. I mean, we've been dealing with Jurassic deposits in Australia that cover, 10 times the size of the United Kingdom. Hunstanton is a relatively small deposit, but it is a very, very beautiful one. You see the brown stuff on the bottom, you see the red stuff in the middle, you see the white stuff up above. Fantastic stuff. These are the names, the conventional names which are given to them. You've got the carstone down at the bottom. Carstone is an interesting word. It actually comes from the old Celtic word for quernstone. You know, quernstone, which you'd use to grind up your grain. Well, in Norfolk, there's not too many hard stones that are very good for grinding up grain, but carstone is one of them. You've got the Hunstanton Formation in the middle, which is unique to the UK, and it's only found in 1 or 2 places, all on the east coast Britain. And Hunstanton is sort of where everybody refers back to when you're dealing with this wonderful red chalk. And on the top, you've got the Ferriby Chalk Formation, or your standard white chalk. Here are your dates. Supposed dates, I should say. The Carstone at the bottom is supposedly 109 million years old. The red chalk in the middle is supposedly 101 million years old. The Ferriby Chalk Formation at the top is supposedly 99 million years old. These are the standard dates. You can find these on the internet, or if you get your geological book out. There's a few different ideas. A few ideas have changed about the dates over the years, but this is the most recent and most up-to-date idea. All right, we need to actually investigate this a little bit further. We know the dates. Let's actually go into the rocks. Let's go into the fossils. Let's use the concept that we learned at Jurassic Ark, and let's actually take it forward. Because Hunstanton is a real beautiful place, and you can find fossils all throughout the red chalk, the Hunstanton Formation, and the Ferriby Chalk Formation, the white chalk. Fabulous fossils like this one. A great big ammonite. You see the curly-whirly ammonite in the middle picture? You see the shark tooth, which is sort of squished up next to the ammonite. And then on the side, you can actually see a sea urchin. We know it's a sea urchin, by the way, because they're still alive today. They haven't changed it one little bit. They've been doing exactly what God told them to do, whether you want to believe that it's 99 million years old or just a few thousand years old. They've been reproducing after their own kind. There really is no evidence for evolution in the rocks at all. You see the layers of strata? You see how the ammonite is laying in the layers of strata, but the sea urchin has actually tipped. It's standing up vertically. Interesting. You see, I made the point there. There's our sea urchin, and there's the modern one, which I picked up off the beach. No change whatsoever. They're exactly the same, reproducing after their own kind, just like God commanded them. What other fossils can you find? Well, you can find these wonderful things. These are brachiopods. In fact, the position that I've shown you there is how you find these brachiopods in the cliff. They're in the side of the cliff, standing up like that. Or should I say, upside down like that. Yeah, here's what they look like. You see the little sort of hole in the top? That's where a sort of a stalk is actually attaches, and the stalk attaches the brachiopod to the bottom of the seabed. There's the diagram there on the left. There's the living creature on the right. That's what they look like. And every single time you find one of these brachiopods in the rock, they're actually upside down, sitting upright through the rocks, sitting upright through all of the layers. It's polystrate. And that actually makes an interesting point when you start to put these dates to the test. Let's remind us of these dates. The Ferriby Chalk Formation at the top, 99 million years. The red chalk in the middle, 101 million years. The Carstone at the bottom, 109 million years. Let's do some maths. Oh, don't worry, it's not too technical. It's a nice simple mathematical equation which you can apply to just about anywhere on the planet. And I encourage you to do so, because what we are doing, we are using an absolute equation, which is mathematics, and we are actually taking the dates and putting them to the test. 109 million years minus 99 million years equals 10 million years. Did you see what I just did there? You take the date at the bottom, the date at the top, you minus it, and you actually get the time that it took to lay this deposit down according to the dates. In other words, it took 10 million years to actually deposit the Carstone and the chalk at Hunstanton Beach. The height of this, about 20 meters or 65 feet. You can test this. It's very easily provable. You just get a very long tape measure, or use shadows or so on and so forth. It's shown to be 20 meters, 65 feet. So we're pitching these dates, which is the only hypothetical thing, if you like, with the very real, very evidenced 20 meters of height, and we're going to stick it into another equation. 10 million years to lay down 20 meters or 65 feet, according to the dates. Okay, let's stick it into a math equation. 20,000 millimeters, or 20,000 millimeters, by the way, is the same as 20 meters. It's just expressed in a different way. 20,000 millimeters divided by 10 million years equals 0.002 millimeters per year. In other words, if these dates are correct, then according to the dates, to lay down 10 million years, to lay down 20,000 millimeters of sediment or 20 meters of sediment, it was depositing at a rate of 0.002 millimeters per year, or 0.00007 inches per year. Okay, or 14,285 years to bury an inch, or 28,000 years to bury this brachiopod. Wow. The point, if you're dealing with these fossils, if you're dealing with deposits, if you're dealing with this, if you actually pitch the date against them, you get ludicrous results. And the point is very simple. Deposition has got nothing to do with time, but everything to do with the process. Get the process right, it happens quickly. And the evidence for it happening quickly is all over the world, even at Hunstanton. Because this little process, this principle which we did, has ended up having lots of critiques over the years, including deposition would not be constant while it's forming. The argument is that as this is forming, I mean, all we've done is we've taken the dates, we've taken the height, we've divided it, and we've assumed that the rate of deposition has always been the same. Okay, the argument, therefore, that they claim is that deposition would not actually be constant when forming. Well, you need to dig a little bit deeper. You need to actually have a look at what evidence is there. What does the evidence actually indicate about deposition? Does this say that this is a gradual deposition? Does it say this is a fast deposition? Because one argument is that, well, you've had bursts of deposition where it's buried really, really quickly, and then it's sat dormant for several 100,000 or even millions of years. And then it suddenly had another burst and it's deposited quickly, and then it's laid dormant again. That's one way of explaining around the issue. But let's have a look at what the evidence actually says. Let's have a look at Hunstanton evidence. Remember, we're looking at what is the evidence of things that have been buried in a flood. Well, you're looking for evidence that fossils have been buried rapidly, just like the logs. Do you remember the point we made? The strata, the layers, had to be deposited quicker than it takes for pine wood to be destroyed or decompose or rot. So we're looking for evidence of fossils buried rapidly. We're looking for evidence of this all throughout the deposit, not just in little bands, not just in little streams. We're looking for evidence all throughout the deposit, and we're also looking for evidence of currents and flow. We're looking for evidence that it's actually been flowing through, that you've got currents just like the logs, you know, oriented in the same direction, abraded and pointy at the end, stripped of their roots and stripped of their branches. Well, we don't have any wood in the chalk deposits. We have wood, by the way, in the Carstone deposit, and that's practically ignored. But we don't have any wood in the Hunstanton deposit. But what we do have is plenty of elongated fossils. They're called belemnites. All right. Let me introduce you to a paper, my first ever paper that I actually wrote and that was published, The Evidence of Transportation and Rapid Burial in the Fossils of Hunstanton, written by me in 2017. It was the result of a 3-month research project into Hunstanton where I specifically looked for the evidence of transportation. In other words, evidence that the fossils had not lived, had not died, and had not buried in their where they were living. Right? Remember, that's the standard story of geology. That's the standard story of fossils, that creatures lived, died, and were buried in place where they were living in their ecosystem. But I've already shown you from the fossils that the ecosystems are a mess. So let's actually have a look and see if there's any evidence of transportation, that the fossils were actually transported into position by water flowing sideways or water flowing in one direction. These fast-flowing currents during the formation of the Hunstanton and Ferriby formations and burying those fossils within them. Well, what did this paper actually show? This, by the way, this paper has been to this day my highest ever marked paper. It's been the highest ever marked assignment. It got 100%. It was put into the university reports and stuff like that. So it's a pretty prestigious piece of information. I'm really pleased that I'm happy that I had the opportunity to do this research and to actually get it published. And also, the word which the professor used when reading it was revolutionary. Why was it revolutionary? Well, have a look at what evidence this research uncovered. 93% of fossils showed transportation. The belemnites were all pointing in the same direction. some wonderful evidence that you can find. And the point is simple. These fossils were formed in water flowing in one direction, being caught up in a slurry of sediment before being buried very rapidly and then fossilized. The belemnites, the pointy creatures, are all pointing in the same direction. The brachiopods, we've already talked about the fact that they were ripped out, turned upside down, buried upside down, standing up through the layers. The very fact that you've got fossils there is evidence that it's been buried very, very quickly indeed, because regardless of whether you want to argue whether it's a slow or gradual, a uniform deposit, if you take those dates and you actually do that simple calculation, there's no way you can get around the fact that all the fossils have been shown to be buried very quickly in flowing water, in water flowing sideways or flowing in one direction, in a slurry of sediment before being dumped down. This is a very, very quick deposit, a very rapid deposit. But Hunstanton Cliffs isn't really that thick. I mean, it's only 20 meters tall. And an important point to remember when you're dealing with fossils is if you want to get a fossil creature, you need to bury it extremely quickly, you need to bury it extremely deeply, and you need to bury it without the presence of oxygen. If you don't get those three things correct, you're never going to get a fossil, because time will destroy your creature long before you actually have a chance to fossilize it. Now, even if you have a sudden burst of deposition and then millions of years of dormancy when the formation of Hunstanton and the chalk formations there, you're still not going to bury your fossils quick enough or deep enough to actually get them into the beautifully preserved state that they are today. Yeah, you need to have a look at the full evidence. A reminder about the Rocks Cry Out project. This is a fantastic new project which we've started a couple of years back, and we're moving forward with speed. What we actually do, and this is if you want to take this point, because there's only so much we can cover in 50 minutes. So if you want to take this point and actually take it forward, I'd encourage you all to check out the Rocks Cry Out. What we do is we travel around the UK to various geological locations, and we film a short documentary about 10 to 15 minutes in length. What we then do is we then publish that documentary for free on our website, therockscryout.co.uk, in all different places that we've traveled around the UK and filmed these on site, on location. It's not just staring at a computer screen or staring at a guy giving a talk. We're actually on the location, digging up the fossils, finding the evidence, and then we publish a field guide with them. You can find out more about this at therockscryout.co.uk. At the moment, we've published 4 different locations, both the book and the video, but find out more about it, because the video is fascinating if you want to learn some real hands-on evidence. The book goes into a lot more detail, as well as giving you directions, as well as giving you information about going and visiting the place yourself and maps, and taking you step by step through the geology. So it's fantastic if you want to go and actually visit the place yourself and have a creation-based field guide to the location. But also, if you are an armchair geologist, get the book, watch the video for free, and actually get a full perspective. 2 of our main ones, we've actually done Charmouth and Lyme Regis. There was a recent film which just went out called Ammonite, which is based on Mary Anning, the famous and fabulous fossil hunter of the Victorian period, but she was portrayed as a sort of with a lesbian lover, and there was all sorts of interesting and false information about her. But you can get the true story about her, as well as the true story of the rocks in the Rocks Cry Out, Charmouth and Blackfen. And if you want to learn the full story of Hunstanton, including a slightly condensed version of the research paper which I originally published, the full version, by the way, is available at therockscryout.co.uk. You can actually get the Rocks Cry Out, Hunstanton Cliffs, watch the video, get involved, and actually find out the true evidence. One final thing as a reminder before I hand back to Simon for questions, we've currently got a special deal going on our website. It was sort of extended from Christmas as a New Year deal. You can get all 4 of these books, plus a whole fossil set, some wonderful evidence for yourself. And don't forget about the code which we set up, AIG, just for this conference. It only lasts for a week, so do be quick about it. creationresearchstore.com, and you get 20% off all of our stock, unique to our creation research. But do remember the Answers in Genesis voucher as well. A reminder, go to creationresearchuk.com, visit creationresearch.net, and if you don't have a chance to ask a question, or you think of a question later on, click on the Q&A, and there'll be plenty more information there for you as well. Well, I think my time is just about up, so thank you very much for having me, and I'll hand back to you, Simon.
Thanks, Joseph. That was really great. It's always helpful when you do your presentations. We do have a number of questions that have come in, and folks, if you want to ask Joseph a question, please do try and get it in the comments section really quickly. Joseph, someone has asked, why are there never human fossils found with other fossils?
The answer to that is that there are plenty of human fossils found mixed up with other fossils, and I'll elaborate a little bit into that. A few years back, John Mackay, our international director, had a debate with Professor Chris Stringer, who is the world expert on human fossils. He works for the Natural History Museum in London, and John asked him outright, how many fossil humans do you know about? And the answer which Professor Chris Stringer gave was around 10,000 of them, including one that I keep in the basement. Right? There are many, many, many human fossils found, and the unique thing about them is that they're all human. Okay, maybe it's not that unique, but the reality is, as far back as you want to go and as far back as you want to find human fossils, they're all human. I mean, some are slightly bigger, some have got bigger brains, some have got more stockier bones, but they're all human beings. There's absolutely no doubt about it. Then there's a massive, huge gap, which is commonly referred to as the missing link, and then you get into definitive ape fossils. There really is nothing in between. So there are many human fossils found, and they're all human fossils. I think where the question may be coming from is, why don't we find human fossils in flood deposited sediments, referring to Noah's flood? We've been dealing with Noah's flood today, and in fact, all of the credible human fossils that we know about are all in what we would call post-flood deposits. Right? So trapped in caves, or trapped in much smaller deposits, or fossilized in that way. Well, a lot of this is actually the idea of why don't we find this in flood deposits actually stems from our idea of the geologic column, which says that in the beginning you had the Cambrian explosion, which laid down fossils, and the next layer laid on top of it, and the next layer laid on top of it, and so on and so forth, all the way up to the present day, right? And you have this sort of evolutionary mindset, in a sense, of millions of years, which is intertwined into the geologic column, even though the geologic column was initially proposed by a creationist. Okay, what's the problem with the geological column? It assumes that layers lay one on top of the other, when if you actually have a look at the evidence, layers actually form sideways in water that's flowing. We've been dealing with flowing water today, water that flows in one direction, carrying sediments with it and dumping it down. So the first thing you need to do is get a proper perspective of how rocks form. Secondly, you need to ask the question, okay, human fossils, how many humans were there at the time of the flood? Well, if you take the Genesis account literally and you count it up, you get to a maximum of a few million, to a more likely estimate of a few thousand to a few 100,000. Now, if you have a look at the flood deposits which you have around the world today, buried in Noah's flood, it is absolutely enormous. You just wouldn't expect to find a huge condensed amount of people if the flood has destroyed it all. Secondly, what was God's purposes for giving the flood? To destroy mankind. I will destroy mankind and every trace of them, right? And one thing that you find unique about human beings, and I don't encourage anybody to go and look up flood or tsunami footage or images or anything like that, because it is quite horrific. But one thing you do find about human beings is when we drown, we have a very specific way of drowning. We bloat and then we float once we're dead. It's a disgusting thought, but it does make a point. If you want to get a human being, you actually need to be caught up in that sediment. And most human beings would have bloated and floated at the time of the flood. Also, remember that human beings are created in the image of God. And this is the final thing that I'll say. Human beings are created in the image of God. We're intelligent. We can think forward with things. And so Noah built a great big boat. I wouldn't be surprised when the oncoming flood came that people also tried to build some boats. Obviously none were inspired by God, so none survived, and at the end of the flood the result was that every single land-dwelling, air-breathing animal was destroyed. Ingenuity to try and get to higher land, to try and hang on to floating debris and so on and so forth. The end result is the same, you're dead, but it does mean that you're not actually caught up in flood deposits. So I'm not too surprised that we don't find fossil humans in flood deposits.
It's a great answer, Joseph. It challenges us to rethink how we think about the flood. Someone else has asked a question, and I don't know if you saw the Bill Nye Ken Ham debate, but Bill Nye said that if there were a fossil animal that were captured in between rock layers, then that would be compelling proof for a flood. What would your take on this be?
Fossil animal that's trapped between rock layers.
Yes, that's what the question says.
Passing up through layers.
I think so, yeah.
Okay. Well, there are multiple plant examples of that in terms of polystrate trees and the like. But the reality is, every single fossil, in a sense, is a polystrate fossil. I mean, if I just quickly let me just see if I can go to my slideshow again and show you this fossil of the ammonite, which we had up a little while back, that was found at Hunstanton. Here it is. Here. Oops. There we go. Let's just see if I can share. Oops, I've lost. There we go. See if I can share this screen very briefly, because what you're dealing with, remember the point that we made when we were dealing with this at the first point, when we're dealing with the rate of sedimentation, you can see this ammonite here, big curly whirly thing, and you can see the layers of strata. All right, now these are big layers of strata. In between those layers, there are hundreds of teeny tiny little layers, which you can see if you stick it under a microscope, right? Now, this ammonite is sitting up through layers. It's an animal, it's a creature that has been buried, sitting up through many layers. Now, each layer is supposed to represent a seasonal deposition, right? A year of deposition or so on and so forth. Here we have an ammonite that cuts up through loads of them. We have belemnites, pointy creatures, which cut up through loads of them. We have animals like the dinosaurs, which cut up through them. You see, the problem is if you take the concept of millions of years of slow deposition and you use the dates like we did and you do the equation and you divide it and you work out that, oh, this is only laying down 0.002 millimeters per year, then anything that gets trapped in that is going to be a polystrate fossil, because you need to have a creature buried very quickly, very rapidly, without any oxygen in an oxygenless sealed environment in order to actually get a fossil. So you need to, yeah, I mean, Bill Nye is correct in his point. There are many of them found all over the planet, but you need to take it one step further and say, okay, well, let's just actually deal with the fossil itself. Regardless of whether you believe it cuts up through layers or not, how did you actually get this fossil in the first place? Because the very fact you've got a fossil shows that it was buried very, very quickly indeed.
Yeah, great answer. Another great answer, Joseph. A couple of more questions have come in. How do you give a quick answer to the asteroid killing the dinosaurs?
The simple answer is that you go onto the BBC and so on and so forth, and you watch Professor Brian Cox, and he says, "Oh, we know that an asteroid destroyed the Earth 65 million years ago." No, we don't. There was a paper published, basically a signed paper published a few years back, where the vast majority of paleontologists, people who actually study dinosaurs, said there's no sufficient evidence for an asteroid wiping out the dinosaurs. It's the most popular view at the moment, but it certainly isn't the only view. If you want some fun, just research ways that dinosaurs died out. And these are all legitimate and very serious proposals that have been put forward. It's not messing about. My favorite one is that cannabis, marijuana, evolved at the same time as the dinosaurs, and their immune systems couldn't cope with being high, and so it killed them off when they all got high and got off their heads. Another very, it's actually in the academic world, it's almost just as popular as the asteroid theory, which is that flowering plants evolved the same time as the dinosaurs went extinct, and it was actually their pollen which reacted allergically to the dinosaurs' breathing systems, and that wiped them off. That's actually very, very popular and a very serious proposal in the academic circles. The biggest evidence that people give for the asteroid sort of crashing in, well, there's two ones. The first one is that big crater outside of Mexico. Well, that crater has been contested. It may well be a crater. It may well just be where the Earth has kind of sunk in. Well, that's excellent evidence for the flood and the fountains of the Great Deep bursting open. So it's not conclusively an asteroid. The other one is what is known as the KT boundary, which goes out across the world, which is sort of a volcanic layer, if you like, which spreads out throughout the world. It's a very, very thin and sort of is in between the Cretaceous and the Tertiary, KT. That's what it stands for. Well, again, there are many different explanations for the KT boundary, including volcanoes, including all sorts of different stuff. It's not conclusive proof that it's a single extinction event. And again, you believe, or scientists believe, that the dinosaurs were extinct at that point because of their way that they view the rocks. They believe the dinosaurs only lived in this very, very thin little segment of time, and beneath it were lots of sea creatures, and above it were apes and ape men and humans, right? So you've got the wrong view of the rocks if you're actually going to interpret it that way as well. But the reality is there just simply isn't sufficient evidence. And this isn't me just saying it. This is well known across academia. There isn't sufficient evidence to say we know that the asteroid wiped out the dinosaurs. There's so many problems, like why did other creatures survive? How come you've got other big reptiles and so on and so forth? But the reality is nobody really knows from an evolutionary perspective anyway why the dinosaurs died out.
Yeah, and we're going to, well, Professor Taylor's up next to deal with dinosaurs, and I'm sure he'll talk about evidence of dinosaurs and man living together in the present world.
Yeah.
One final question, Joseph, and then maybe there's lots of questions have come in. So if you want to go back into the chat after you've gone out, then that might be helpful. But someone said, the flood was just over 4,000 years ago, which wasn't much time before civilizations emerged. So loads of people would have died and been buried not long after the flood and haven't been fossilized. Of course, these people I'm talking about weren't buried under catastrophic conditions. So how does a catastrophic flood burial make a bone or a shell turn into rock or mineral quicker?
Okay, very briefly look into the process behind how you actually get fossilization. So when you're dealing with a dinosaur bone or when you're dealing with a human fossil bone, your bone is still there. The very bone which was inside that dinosaur or inside that human being is still there. What often happens is it becomes permineralized. Permineralized or permeated with mineralization basically is where you have a mineral substance in the rock which is its surrounding, which permeates the bone, infills and entraps it with minerals, and so you get a fossil bone, right? Now this can happen very, very, very quickly, even in what you would consider normal conditions. Case in point, and I wish I had the slides here but I don't, we had a sand pit built at Jurassic Ark. Now Jurassic Ark is Jurassic sediment. It's very, very full of iron, right? The whole sediment layer. Now, what we wanted to do was to teach our students how to dig up fossils before they went and dug up real fossils, right? So they don't go and destroy them. So we built a great big sand pit, filled it with local sand from around Jurassic Ark. It's a sandstone, right? And we buried some bones in it, just ordinary bones. We have a hunter friend, so we had cow bones, we had deer bones, we had just general butchered bones, right? We buried it in there. We covered it up with sort of a fabric, but it still let the water through, which we didn't realize at the time. And the problem was it then hit the winter season, for our winter season, which is the Australian summer season, which is extremely boiling hot and nobody ever turns up, right? So it was left for ages and the water actually seeped up from the ground and went into the sand pit, right? When we started getting visitors again and we uncovered it and actually began to dig it up, the pure white bones had turned nearly black and a very, very dark brown. And they were extremely heavy and they were permineralized with iron in just the space of a few months. And so you take the bone out and you do some chemical analysis on it, and the infilled material is extremely high concentrated iron, which is soaked into the bones, right? For all intents and purposes, this is a fossil bone, and it happened in just a few weeks, right? The point is, in order to get a fossil, you need the right process. Okay, get the right process, it can happen very, very quickly. Have the right minerals in place, it can happen very, very quickly. So when you're dealing with post-flood fossil bones, there's a very famous one discovered not too far back where it was a Neanderthal person in Northern Europe, and he had apparently died and been laid to rest, actually sort of buried in a sense, in a cave. And the stalactite and the stalagmites and the dripping limestone had actually completely entombed his entire skeleton. He was a fossil skeleton. He was entrapped in limestone. But you can get, what you find is if you take a biblical picture, and this is the last thing I'll say, a biblical picture, an enormous worldwide flood, ripping up the Earth's surfaces. When you get dry land again, the Earth's surface is still going to be very mobile. It's still going to be, there's going to be lots of after effects, lots of shocks, lots of moving. Plus, you also have the perfect conditions for an ice age. And you can find plenty of information about the ice age on Answers in Genesis website. And you find that you have a very quick ice age coming on and also retreating very quickly, which causes catastrophic burial and causes catastrophic flooding. Not worldwide flooding, but on much, much, much bigger scales than we actually see today as a result of a worldwide flood. So the key point to take away, if you want, from the entire talk is, if you're dealing with geology, fossils, it's about process, not about time.
Yeah, I'm glad you emphasized that, Joseph. It's always a great point to keep in mind. It's not about a process, it is about time. And Joseph, we've got many people really appreciate your talk that you've given this afternoon. It's been a blessing to us. If you want to go back in and answer some of the questions, there were a lot
Absolutely,
more there.
I will, yes.
That'd be a great help. But thank you for being with us, Joseph. That was really
It's been
good.
wonderful. Thank you very much.
Thank you.